Oh, hi there, and welcome to a brand new section, Section 6, Advanced Building Blocks, Part 1. So, let's go to a very quick section overview where we're going to see everything that we're going to learn in this section. So, our goal for this section is to continue learning those modular Lego bricks or base or building blocks that we have been learning so far, but now we're going to take a look at more advanced building blocks. So these are stuff that maybe you're not going to use in every single API that you make, but are tools that are very good to have in your tool belt available if the case comes where you need to use them. So if you have clients that need to use these tools, or if you have specific demands that require, these are things that you should always have in mind. So for this video, we're going to start seeing those advanced Lego bricks, and the ones we're going to see in this section is scalability. So we're going to learn how to how to implement your application in a way that's scalable so it can be distributed. We're going to learn all about that and why that's important. Okay, we're also going to take a look at performance, and we're going to see how to build more performant APIs and to make sure that our APIs do not take too long to respond. Okay, and if they need to, so if there is some task that's very demanding that takes too much, we're going to learn how to use background tasks to make that experience easier for the user to implement, for the clients to use.
This was a quick section overview. Now let's go to this video, scalability. So the goal for this video is to learn about stateless and distributed applications and to understand the idea behind cache and why it's so important. Okay, so we're going to learn how to make our APIs more scalable, how to be able to tend to more people's demands. So let's say your user base has grown exponentially and you need to be able to do something to do that. Okay, so when we talk about scalability, we probably have two concepts in mind. There's two ways for to scale. So let's say you have your machine there, that's your server, that's running your API code that we build or to do API, and you have 1,000 users, okay? And those 1,000 users are really happy with the service and the API is able to serve them, but then suddenly now you have 100 times more users. Okay, so now you need to do something, otherwise your single machine that you have there running your server is going to get down. It's not going to be able to support all of those users at the same time. And there are two ways in which you can scale, and we talk about these ways being horizontal scale and vertical scale. So what's up with that? So let's first go to a quick example. So let's say this is your server, okay? So this is the single machine that you have before. So there's one natural thing to do, and that is, let's say you have more users now and you need a bigger machine. So you go there and you buy more RAM, you buy more disk, you buy more processors, you add that to the single machine and you get a bigger machine. And then let's say you have even more users, and then you go to the shop, and now the pieces are start to get really expensive because you're reaching the end of the possibilities. So you have the latest possible processors, you have an array of GPUs, you have a lot of RAM, and then you get an even bigger machine. Well, this is the easiest way to scale because you don't need to change anything about the software. The software remains the same, but you scale the machine. However, this is not sustainable. You can't go on forever with this model. And the more you go, let's say that if you have 1,000 users for to add another user, it's cheaper. If you have 1,000,000 users to add another, it's very, very expensive because the prices are not linear. They get exponentially more expensive. So this is a more naive approach. It works if you have limited users. Even if you grow a bit, you can still do this. But in the end, if you grow a lot, this is not sustainable. But what other options are there? Well, let's go back to our single server here, as in the beginning. And now you start to get more users. Then what do? Bigger server? No, instead of that, you buy a new server. So you get a second server, okay? And you add those two to the one you had, and now you have 3 servers. So these 3 are exactly the same machine that you had before, but you are running 3 instances of that machine. You know, and if you have more users, you add more machines, and you have even more users, you add even more machines, and that is fine. You know, this scales linearly, so it doesn't matter how many machines you have. If you want to add another machine, it's the same price because all machines are equal, therefore they have the same price. The problem with this approach is that it's not that easy to do this. Why is that? Because now you have several servers running your code concurrently. you know, and now you need to make sure your code is able to deal with this. You need to make sure that your application can handle the fact that there are a lot of people running there at the same time. And what we're going to see in this video is what we need to do to make sure that that happens, okay? There is one image that I like a lot about this process, and I got this image from this link below. It's an article about this topic. It defines why the naming, why horizontal and vertical scaling. So it's like you have buses, and you can see in this image that when you go vertical, you increase the size of the same bus, but when you go horizontal, you get new buses. And you can easily see that vertical scaling is not sustainable. You can have buses with 2 floors, that's fine, maybe even 3, but you can have a bus with 4, 5, 10 stores. That doesn't make any sense. You need to have more buses in order to scale properly, okay? But as I said, horizontal scalability requires distributed systems. And what does that mean? That means your application needs to be prepared to handle having multiple instances. So you can never, for instance, save something very important to your memory, because then the other instance is not going to have access to that. You cannot, let's summarize all this, you cannot have state. So we said before about stateless versus statefulness. If you have a stateful application, it's very difficult to scale horizontally. And that's why REST is really good, because REST is stateless. REST does not have state. And that's incredible, because it means that out of the box, if you did a proper REST API, it's going to be able to scale horizontally without any problems, okay? And that's really good. That means that nothing can be saved in the memory of your single machine, because you can have multiple machines and they're not going to share their memory. If you need to save something, you need to save to the database, okay? But there's one important note here. Let's go back to the word nothing that I said. So nothing can be saved in the instance. There's not a single thing that can. Well, actually, there is one thing that you can save in the memory, and that thing is the cache, okay? So even though your application is stateless, it's okay if you want to save cache to the memory. Cache is something that if, for instance, let's say you have a first request goes to machine 1 and then it saves cache. If second request goes to machine 1 again, that can happen, you use the cache. Great, you save time. If, however, it goes to machine 2, you don't have the cache there. But that's fine, because your application needs to be able to work without the cache. Let's assume the cache fails always. Okay, your application needs to know how to work in this scenario. The cache is there to help if it's possible. If you have lucky and you get the cache, okay, great, you save time. Otherwise, your application goes to the database and it knows how to handle the situation, okay? So there are 2 possible ways in which you can build cache. You can have in-memory cache like I described, okay? And that's the easiest way, because it doesn't require any new infrastructure. This kind of cache has some peculiarities. So you're going to save a cache in your own instance. You cannot trust this cache forever. Okay, so depending on the API that you have, on the resource you are talking about, you can decide how much time you're going to have for cache. Okay, so let's say you have a 10 minutes cache. So you are never sure if the information is up to date or returning. Maybe 9 minutes ago someone changed that in the database and this instance doesn't know because it's using its cache. So you have to be aware of that. If it's an entity that you barely ever change, that's fine. You know, you can have a 10 minutes cache maybe. But if it's an entity that you change all the time and you want to have up-to-date information, maybe you have a 10-second cache or 20 seconds. Or maybe you don't even have cache at all. Another option is to have distributed cache. Now, this is an even more advanced implementation that we're going to build, and that's going to share cache among all your instances. One way to do that is to use Google App Engine Memcache. So Memcache is a really nice way to build distributed cache. You can, using Memcache, invalidate the cache for all instances at the same time. So that's pretty much like a very fast database, but it doesn't guarantee that's going to persist values. So maybe you save to the cache and it doesn't. Apart from that, it's like a database in the sense that it's a single instance that's accessed by all applications, and this instance is distributed in all your machines. Okay, so if you are using something like Google App Engine, I do recommend distributed cache. Otherwise, you can implement in-memory cache, which is easier and is already going to give you some boost in your performance.